Now, our two algorithms seem to be giving us something different for t equals 8 and x equals 79. So let's see what might be going on. But I'm not sure, I'm pretty sure this ends up with 3, okay? Because when you get done here, your remainder is going to be 7. And when you add that to 8, you get 15. And when you subtract 12 from 15, you get 3. So I'm not sure. About half of you got 3, half of you seem to have gotten 11. Okay. So now z equals 6 7/12 minus 6, which is 7/12. Okay? And now z is 12 times 7/12, which is 7. Now we're down to this step. And z is now 15, right?
Yes, sir.
Everybody agree up to this point?
Mm-hmm.
Okay, so now we got to go back here, right? Now z is greater than or equal to 12. So z is 15. And now z is 1 3/12. Okay? And then, I don't have room to write out the details, but if you subtract the floor, which is 1, from 1 3/12, you end up with 3/12, right?
I got 1 and 1.
Huh?
That's just.
Oh, I was just getting it.
Okay, so z equals 3/12, and then you multiply that by 7 and you get 3. Uh-oh. And you're starting at t equals 8, so you got to add 3. It might be that the people that got 3 didn't complete this step. So,
Well, I just subtracted 12 from 15, so I think that you should just put like if z is greater than 15 at the end, you just subtract 12 from that. How you get 3. You shouldn't like repeat the whole equation if you're over 15. You should just
yeah,
subtract
the
12.
problem is if you got 3, you never added it to 8, because 8's where we start. No, actually, you did add it to 8. So, but, yeah, okay, the algorithm's wrong,
What?
What?
okay?
I thought you go through the whole cycle twice, so you would add
Yeah,
8
no,
again.
the algorithm, yeah, I mean, if you got 11, you did follow the algorithm.
So you're not
okay.
supposed to do the second
But there's a
step again?
flaw in the
Yes.
algorithm, okay? Where I said replace z by z plus t, you had already done that. Okay?
Where?
When you got the 15. When you got 15 here, there's your t, right?
Yeah, but you said to repeat all the steps again.
I did. So you did the algorithm right, but the algorithm is wrong.
So we don't repeat the last step?
Yeah, so we got to revise the algorithm. We got to debug it. Okay, meaning
So we got
that you want to not do this. Okay.
You kind of got it right. Okay.
But that is going to require some revision. So that's going to be a homework problem. How do you fix this? Do you understand what the problem is? The problem is we added t twice.
Don't do it a second time.
Yeah, well, you can't write don't do it a second
I don't
time.
understand
Yeah, I
why we
can-
don't
I
do
You
just
got to
this.
did.
write a very simple instruction.
How come we do everything else twice, but not that?
If you do it a second time, you're adding 8 again the second time.
When you've
Yeah,
already
you got
added
that. So your question is, how do you do that? So I'm going to ask you to come up with some creative ideas.
so that no
Okay.
answer's wrong when we answer that.
There are a number of ways you can do it.
So neither one we can be wrong
Okay.
when we answer that question.
Why do you not add it a second time? What's wrong with it?
Because then you're adding 16, so you're saying that the
Yeah,
time
well-
is 16.
Only if
What you
Z
want to
is-
do ultimately is you want to take the remainder here, which is 7, right? And add it to this. That tells you, now, well, that gives you 15, okay? And there's a problem with that because now you got to deal with the 15, okay? But you don't want to add 8 to it again. You know that if you get 15, that means it's really 3, right? Because this is where the clock would be. I mean, the clock would have gone the same as it if it did 15. I'm going to let you think it through. Think it through in terms of a clock. I don't want to explain it all to you. This is something that's manageable, but a little bit challenging because you're not used to thinking of algorithms. Okay, now, when you do the other algorithm, it requires lots and lots of steps if x is a big number. Because the other algorithm just basically says you subtract 12 and you keep repeating subtracting 12, right? So for 79, you're going to have to, there's 6 steps in subtracting 12, okay? And then you're finally going to end up with 7, it'll be less than 12. And then you're going to have to add that to t, which is 8. But the way that algorithm's written, it's correct, it works. So we have an incorrect algorithm here. It works fine as long as you don't end up at this stage with a number greater than 12 and have to go back. But if you have to go back, it screws up because you're adding t a second time. Okay? The other one doesn't screw up, but if you give it a really big number, if I say x equals 5,487,326, what are you going to do? Well, you're a lot better just dividing by 12, finding the remainder, and dealing with that, right? Then subtract, 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 subtract. Okay? So this algorithm is much more efficient. It's just that it's screwed up.
So if
And there are many ways you can repair that screw up. So I want to see what you come up with. Okay? Make sense?
So there's no wrong answer to that.
You what?
So there's no wrong answer? Like,
Well,
and how you fix
yeah,
it?
if it's fixed, it's not wrong, although if it's fixed, you might fix it in such a way that a computer wouldn't know how to implement it. And we'll see what that means. Okay? Simple steps involving simple arithmetics and simple decisions. Don't say punch this into your calculator.
Punch this into...
And incidentally, if you're using a calculator to do this, you really should be able to do this in your head. If you're having to punch buttons for this arithmetic, which involves nothing more than dividing 79 by 12, you're too dependent on your calculator. There are things that you can't think about because you're not thinking about the numbers, you're just accepting calculator output. You might be doing that very efficiently, which is good, because if the numbers are really nasty, you're going to have to do something like that. Okay? But if you can't do arithmetic with numbers at least up to 12, like division by numbers up to 12 and multiplication by numbers up to 12, you're too dependent on your calculator, and it's going to bite you later. Okay, it's going to restrict your ability to think numerically. Okay? Ideally, you should be able to do it up to 20. Okay? And that's not really hard to do. You just got to kind of make yourself do it. So it's one of those things that really I kind of think is important. You don't have enough number sense if you're using a calculator for this. So get in the habit of taking your calculator and putting it in an impenetrable safe that has a really long combination, so that you won't go to the calculator unless you really need it. Okay? It's really overused. You really have been allowed to use it for things that you shouldn't have been. Okay? You can fix that. Your mind's still flexible enough to be able to do basic arithmetic. And if you're doing fractions by plunging it into the calculator, yeah, if the numbers are really big, you have to. It's ridiculous. You know, it's ridiculous to use the division algorithm to divide like a 4-digit number into a 17-digit number, right? It's ridiculous. Calculator's great for that, okay? Don't let the calculator dominate your life for numbers less than 144, preferably not for numbers less than 40. Okay? You should be able to do these things. You should be able to find remainders quickly.
I'll put away my calculator if you use liquid chalk.
You what now?
Ooh.
If you use liquid chalk, I'll put my calculator.
Oh, that's a deal I'll take. I'll experiment with liquid chalk over there. Okay? And it's break time.
You made that.